Okay, welcome to another video. Today we're going to be looking at the quadratic formula, mainly why we need it, how we can derive it, and then we're going to look at an example on how to use it. So hopefully you can see why it's useful. Now, let's start. So let's consider a quadratic equation like this. X squared plus 3x plus 5. So we'd normally factorize it into something like this. Two brackets, each starting with an x. And we'd look for two numbers that multiply to give 5, and the same two numbers that add to give 3. Now, upon looking at the factors of 5, well, there's only two of them because 5 is prime. And you should be able to see that any combination of adding these two is never going to give us 3. So the only other way that they can both multiply to give 5 is minus 1 plus minus 5, which equals minus 6. So we can't solve this by factorization. Can't solve by factoring or factorization. So this is the reason why we need the quadratic formula. Now we could also do something called completing the square, but that's not really what we want in this position. We want to know the roots of this quadratic equation. Now, before we start on deriving the quadratic formula, I want to just remind ourselves of how to complete the square, because that's what we're going to need to do. So let's look at a quadratic equation like this. X squared plus 6x plus, 5. Right, to complete the square, remember, we want to get this of the form x plus something squared. And to do this, we need to half this coefficient here. So 6 times by a half or divided by 2 is 3, which tells us that this number is going to be 3. Right, so that's what it looks like, x plus 3 squared, but you should know that we need to correct for a term. So we only want to put this bit into brackets, and x plus 3 all squared gives us x squared plus 6x plus 9. So we need to actually take away 9. And we've still got our plus 5. So in completed square form, x squared plus 6x plus 5 equals x plus 3 all squared, and then tidying this bit up here, we've got minus 4. So that's just a brief reminder on how to complete the square there. Okay, let's actually derive the quadratic formula, the important part of this video. So suppose we have a quadratic equation ax squared plus bx plus c. And because we're looking for the roots, we're looking for what x equals. This is equal to 0. Right, a, b, and c are just some numbers. And essentially what we want to arrive at is this formula here. You should know it. So it's minus b plus or minus square root b squared minus 4ac. And this whole right-hand side is divided by 2a. So what's our first step? Our first step is to divide through by a. We want to complete the square, and so we need to have this x squared with a coefficient of 1. So this is going to give us x squared plus b over ax plus c over a equals 0. Okay, we've not done anything too fancy there, we're just dividing everything in the equation by a. Now, let's look at this little bit here. We want to complete the square on this. So, remembering how we did that in our earlier example, we have a bracket, we have x, and we need to divide this coefficient here by 2. Well, I'll just do that over here. b over a divided by 2 is just the same as b over a times a half. That's just a basic rule of fractions there. Remember, you flip the second fraction and change the operation to multiply. So this is b over 2a, which means our term here is going to be b over 2a. This is all squared. And remember, we need to subtract the square of this term here. So we take away b over 2a squared. Remember, that's just to correct for when we expand this bracket. And we still got c over a here. So let's tidy this up a bit and then we'll carry on. Okay, so our next step, we're going to leave this first term alone, so x plus b over 2a squared, and we're going to have a look at this term in brackets. Well, it's just b squared over 4a squared, and we've got plus c over a equals 0. What we're going to do is move these two terms over to the right hand side now. So let's go ahead and do that. That's just going to give us x plus b over 2a squared equals, well, b squared over 4a squared minus c over a. Okay, so we're making really good progress now. Let's carry on. This right hand side of the equation, we want to tidy that up a little bit and make it over one single denominator. So to do that, we need to multiply this term here by 4a on both sides. So that's going to give us x plus b over 2a squared equals b squared over 4a squared minus 4ac over 4a squared. Okay, and then we can just quickly write this right hand side together. B squared over minus 4ac over 4a squared. So you can see now it's starting to look a little bit similar to the quadratic formula. So now we have x plus b over 2a squared equals b squared minus 4ac over 4a squared. So hopefully everyone's following so far. What we now do is square root both sides. Square root both sides. And one really important thing you need to remember is that when you take the square root, you're taking the plus and minus square root. So on the left hand side, because it's a square, we're just going to get back x plus b over 2a. And on the right, we are going to get plus or minus the square root of b squared minus 4ac over 4a squared. Okay, and so we're nearly there now. All we need to do is move this term across to the right hand side. So we're taking away b over 2a from both sides. So this gives us x equals, it's going to be a negative, so minus b over 2a plus or minus, then we've got this big square root term, b squared minus 4ac over 4a squared. Now, just off to the right here, I'm going to have a look at the square root of 4a squared. Well, this is the same as the square root of 4 times the square root of a squared. The square root of 4 is just 2, and the square root of a squared is just a. So we can simplify this a little bit further. Minus b over 2a plus or minus square root of b squared over 4ac divided by 2a. And finally, our last step is just to put these into one fraction. So it's minus b plus or minus square root of b squared minus 4ac divided by 2a. And that is us done. That is the quadratic formula. So now let's have a look at an example. Okay, here's our example. It's a similar example to earlier, only we've just got the coefficients switched around. So we've shown that if ax squared plus bx plus c equals 0, then we can solve this. That means find the values of x using this formula. Minus b plus or minus the square root of b squared minus 4ac divided by 2a. So all we need to do now is identify the similarities between this equation and this one. That means find the values of a, b, and c. So the coefficient in front of x squared is 1, which means our a equals 1. The coefficient in front of x is 5, which means b equals 5. And finally c equals 3. So now all we have to do is input a, b, and c into here. So this will give us that x equals minus b, so that's minus 5, plus or minus square root of b squared, which is 25, take away, and it's important to bracket here, so 4 times a is 4 times 1, times c is 3, and we're dividing by 2 lots of a. In this case a is 1, so it's just 2. We can clean up the square root bit a little bit, so it's minus 5 plus or minus. Well, 25 take away 4 times 1 times 3. This is 25 take away 12, so that's 13. So that's our answer. This gives us that x equals minus 5 plus root 13 divided by 2, or x equals 5 minus root 13 over 2. And that's how to use the quadratic formula there. So hope you enjoyed. Thanks.